So ATP classified paper 6 balancing experiment question number 4. A student investigate the balancing of a meter rule or a meter scale, and you can see the arrangement. P and Q are the two loads which are placed. By looking at this figure, can you identify which one is heavy? Is it P or Q? Like if we look at this distance and I say this is at 40, as they mentioned, X and Y. So X is at 40. So this is 40. This one is 40. This one is at 50. Which load is heavy, P or Q?
P.
P is heavy because P is closer to the pivot, so it is causing a greater turning. Like if to for weight into distance from a pivot, so Q is lighter. That's why it is away from the pivot to create a same turning effect. So we can balance them on a meter rule or a meter scale. So a student places a meter rule on the pivot at 50 centimeter mark. He places an object Q on the meter rule at the center 90 centimeter mark. He placed a load P, which is 2 Newton, on the meter rule and adjusted the position until it is balanced. He measured the distance X from a center of a load to the pivot. He repeat the procedure with load P is equals to 3 Newton, 4 Newton, and 5 Newton, so on. And then he repeat the procedure using a load P3, 4, 5. So we have to calculate the value for 1 over x. What will be the value for 1 over x? Like reciprocal of x. 1 over x means like 1 divided by 40, 1 divided by 27, 1 divided by 20, 1 divided by 15.9, 1 divided by 13.3. You can use a screen annotation to complete this table. The value for 1 over x. 0.025. So all the values should be in same decimal place. Like example, if the first value is 3 decimal places, so the second should also be the 3. So these are the values for the 1 over x. The next we have to plot a graph. That's why I was copying that. Plot a graph for P on y-axis, and both axes must start. Look, see, they specify here that you should start from 0. You cannot start with any other number. So we have P on y-axis and 1 over x on x-axis. So here we need 1 over x. And here we have P. 1 over x, and the unit is 1 over centimeter or centimeter inverse. So, and this should be 0. If it is 0.025, because the values are so small, so this will be 0.025, this will be 0.050, this will be 0.075, this will be 0.100, and this will be 0.125. So it's like 25, 50, 75, 100, 125. These are the values for 1 over x. So this was 0, 0.025, 0.050, 0.075, 0.100, and 0.125. And the value is 1 over x. For P, we have to start again from, so we have to maximum reach 2. So if it is like 2, 4, sorry, we have to maximum reach 6. So it is 1, 2, 3, 4, 5. It won't finish. So if it is 0, then 2 is there, then 4 is there, 6, then we have 8, 10. So because if I choose 1, 2, 3, 4, and 5 will be there, but I don't have 6. So that's why I cannot count as 10 boxes equals to 1. Now, plotting the results. So first, when P is 2, 1 over x is 0.025. So this is one of the value. Then 3 and 0. Basically, it's like 37 because 0.25 and each box is representing, because like each box is representing 0.0025, as 10 boxes equals to 0.025. So if I divide by 10, each is 0.0025. So between 35, between like this is 0.25. Even I can reduce this axis. See, I can also simplify this axis, right? Also, I can write them in exponent. Like I can write this as the value of 1 over x is 25 into 10 to the power minus 3. I can do in this manner. So it will be, the second value will be 37 into 10 to the power minus 3. Then the next value will be 50 into 10 to the power minus 3. The next value is 63 into 10 to the power minus 3. And the next value is 75 into 10 to the power minus 3. So if all are in the same notation, so scientific notation, so what I can do, I can even label the axis in this manner. This is also the right way, that because 0.0255575 very small values are there. So what I can label, I can label that this axis is equals to, like this is 25, then 50, then 75, then 100, 125, and then this axis is multiplied by 10 power minus 3. Like it is 25 into 10 power minus 3, 50 into 10 power minus 3, 37 into 75 into 10 power minus 3, 100 into 10 power minus 3, and 125 into 10 power minus 3. So both ways are acceptable. Like if you write in decimal or you write in exponent form the axis, it's fine. So this is actually 37. So where you will write 10 power minus 3, you will, on the axis you will multiply. Like you can write for the overall axis, or you can write with these numbers as well. Both ways it is correct. Like if you write this is 25 into 10 to the power minus, so if you write 25 into 10 to the power minus 3, then you write 15 into 10 to the power minus 3. You write 75 into 10 to the power minus 3. You write 100 into 10 to the power minus 3. You write 125 into 10 to the power minus 3. This is also fine. Or you multiply 10 power minus 3 with the axis, that's also fine. So we have this like 25, this is 37. So each box is representing like 2.5, 10 boxes on. So this will be 27.5, this will be 30, 32.5, 35, and this will be 37.5. So 3 and 37. So this is 3 and 37. Then 4 and, so this will be 4 and 50. Then 5 and 63. So this will be 52.5, 52.5, 55, 57.5, 60, 62.5, and just about 62, near 62.5 and 3, and then 75, 6 and 75, so 6 and 75. So these are the points which we mark. and we'll always draw a line of best fit. Sometimes all the points lie on the same line, so that is the best fit straight line you can see. And even it's starting from origin, like when we join these points, it's a straight line which is passing through origin. So if it's a straight line passing through origin, what it shows? It shows that P and 1 over X are directly proportional to each other. Is it clear about the graph plotting this result?
Yes, sir. Clear.
So the next part, in the question, in this experiment, X max is the maximum possible value of X is 50 centimeter. Calculate 1 over X max. So the maximum possible in the experiment, as I mentioned, the X max, the maximum possible value of a X is 50. Calculate 1 over X max. So how to calculate 1 over X max? So 1 divided by 50. What's the answer for 1 over 50?
0.02.
So 0.02 will be there. And you can also work out from the graph as well. Because if X is equals to what we want 1 over X max. And the maximum value of the X is 50. So this is 0.02. Use the graph to determine the value of a minimum value of a P required to balance the meter rule and show how you determine this value. So look, when the value of X is maximum, the value of the P should be minimum. How we work out that value of a P should be minimum? Because look, when we are in, the idea is that we are changing a load here. Like when we did this experiment, first we add 2 Newton and we measure this X. Then we add 3 Newton. Then we add 3 Newton and we'll get the value for X. Then we add 4 Newton, we'll get the value for X. So if we are increasing a load, the value of X is decreasing. And same thing they're saying that if the value of the X is maximum, if we increase the value of the X maximum, the value of a load should be minimum. So we want to determine what is the minimum value of the load. How we can determine the minimum value of a load? So we work out in this experiment the X max, the maximum possible value of a X is 50. So if X is 50, we take 1 over X. So 1 over X is equals to 0.02 in the experiment. Then the next part, use a graph to determine the minimum value of a P. So the idea is that, as you can see, if the value of the X is increasing, the value of the P is decreasing. So, and if the value of the X is increasing, the value of 1 over X will decrease and the value of the P will also decrease. So what we have to do from our graph with a value of 1 over X as 0.02 or 2 exponent minus 3, we have to determine the value of a P, the minimum value of a P. So this is our graph. So this is our graph and we work out the value for 1 over X, the minimum value of 1 over X, because the minimum value of 1 over X, using the minimum value of 1 over X, we can determine the minimum value of P. So this is 2.5, this is 5, 7.5, 10, 12.5, 15, 17.5, 20. So this is 20 exponent minus 3, or which is also 0.02. So from minimum value of X, will determine the value of the minimum value of P, which is, according to our graph, it is 1.8 Newton. So this you have to show on your graph, like from minimum value of the 1 over X, like when the value of 1 over X is small, the value of the P will also be small. So the question is, what is the value of a P when the 1 over X is 0.02? So that's equal to 1.8 Newton. Is it clear, this part? Because the question is, use your graph, determine the minimum value of a P required to balance, and show clearly on the graph how you determine. To get the minimum value of a P, we should have a minimum value of 1 over x as well, and or a maximum value of x or minimum value of 1 over x. So from this value of 0.02, we determine the load, which was 1.8 Newton. Is this clear, this part?
Yes, sir. Clear.
The next part, in this experiment, the width of a load Q is slightly greater than the width of a meter rule. Look, for example, if this is a meter rule or a meter scale, we are looking from the top, not the, if we are looking from the sideways, it will look like this. But if we are looking from the top, I will draw both ways. Like if you are looking from the sideways, it will look like this. But if you are looking from the top, it will look like this. So the question is, the width of an object or Q is greater than the meter rule, like the width of a meter rule. So if the width of the object is greater than the width of a meter rule, so you won't be able to where the center lie. Like I cannot identify that where the center of the Q will lie. So what I can do, how would you place a Q exactly 90 centimeter mark? So how we can identify like it is exactly at 90 centimeter mark? So what we can do, the average of the two values, like for example, if this is say 88 and this one is 92. So the average of the two values should be equal to 90. When we place a meter rule and we take average of the two readings before and after, the average of the two readings should be 90. So we can identify that the center will lie at 90 centimeter mark. Same thing here. You can draw this figure as well. Say this is 88 and this is 92. So where the average of 88 and 92. So it will be 88 plus 92 divided by 2. So the average will be 90. So that will be here. So how we can estimate that the center lie at 90 centimeter mark? So when we are the size of the object, we cannot see the scale. We cannot see where is the 90 centimeter because the size of the object is bigger than the size of the width of the rule. But we can only see the reading before and after, because that will be visible. There will be markings here, but we cannot see under the object, we cannot see any markings. So if we cannot see any marking, how we estimate that the center is at 90 centimeter mark? So we'll measure read the values before and after, and we will take average, and that should be 90. That's how we estimate that the center of this load is 90 centimeter mark. So this object, as you can see here, load Q, we say this is at 90 centimeter mark, but how we will know that it is at 90 centimeter mark? Because we cannot read the scale. This object is covering the marking of the meter rule. So if we cannot read the scale, how it can be done? So what we do, we measure, we record the value here, the first value, maybe it is 89. And we record the second value, maybe it is 91. So what is the average of 89 and 91? The average will be 90. So that's how we estimate the position of a load Q. Or there is also another method, like you just have a marking on the center of this. Like there is a marking on the load to exactly estimate where the center is lying. But that method is not the simple one. So the most simple one, we just estimate, like measure a distance before and after and take an average. And that average should be 90. If I say load Q is placed example at 20 centimeter mark, how you will show that load Q is at 20 centimeter mark, or the center of the load Q is at 20 centimeters. So what you will do, you will measure the distance before and after. Like this is 19, this is 21. So the average should be 20. Is it clear?
Yes, cool.
This is the same question. If you check the notes which are given to related to the topic, in the beginning of the topic, these are the notes given. Like example, how we show that difficulties are there. The center of mass of a cylinder may not be above X. So how you estimate? Like you take distance before and after and take an average. The same idea. So how you find the position? The next part E. In this experiment, it is difficult to determine the exact position of a load that will make the meter rule balance. Explain why this is difficulty. So why this is difficulty? Because of this, the meter rule will slip. Difficult to obtain a balance point, or the meter rule will slip. That's why it is. Then how would you find the best position of a load that make a meter rule balance? So how we can do this? We simply estimate the position before placing a load on a meter rule. So always we do this estimation before we place a load on the meter rule or meter scale. So this is all a common difficulty in this experiment, a balancing experiment, that the meter rule topple or slip when we try to balance. So we just estimate the position before we place the load on the meter rule. Then the last question from this ATP balancing experiment, a student finding how we estimation is there. Like example, if I know it's just an estimation. If I know, like example, we place a load 2 Newton and we check, first we will check, like example, which position it is balancing. The previous question 3 was question 4. So here we have load Q, we know load Q and we know load P. So we just estimate. First time what we did, first time we place both loads and we find at the same distance, and we find where it will topple. Like example, if it move clockwise, it means load Q is more. If we place equal distance and it move anti-clockwise, it means load P is more. So the first thing what we do, we place the two loads at the same distance on the pivot and we find which direction it topple. So the direction in which topple, it means that load is more. So the one load should be away and the one should be closer. The one which is heavier should be closer and the one which is lighter should be away. So first we estimate the position, like what should be the likely positions, which load should be closer and which should be away, and then we start balancing. Is it clear, this point? So we always estimate the position before starting our experiment to have an idea that which is heavy, which one is lighter. Then question 5, a student is finding the weight of a meter rule using a balancing method. So P and Q are the two loads which are placed, as you can see here. The student places a meter rule on a pivot. He places a load P, which is 1.5 Newton at 90 centimeter. and he keeping P at 90 and he adjusts it so that it is balanced. And in a table, record the distance from distance A from the center 50 centimeter mark, and then calculate and record in a table the distance B between the center of a load P and the pivot. So he record that A is 50, the pivot is there. So he recorded that the distance A from the 50 centimeter mark to the pivot, and you have to calculate and record table 1.1 the distance B between the center of the load and the pivot. So this one is at 50 centimeter mark and this one is at 90 centimeter mark. So what is the total distance from 50 to 90? That is 40 centimeter. Out of 40 centimeter, A is how much? A is 23.1. Because this total, as this one is at 50 centimeter mark and this one is at 90 centimeter. So this distance is 40 centimeter mark. And out, this is 23.1. So how much is this distance remaining? Out of 40, if this is 23.1, what is the remaining distance? So that will be 16.9. So we just have to write here, yeah, 16.9 centimeter. That's a question that what is the distance B here? So B is equals to 16.9. And then A divided by B. What is A divided by B? Like 23.1 divided by 16.9. Write the value here. 1.366 or, okay. Then we have to plot a graph for P and AB. So 1.5, 1.2, 1.0, 0.8, 0.5, and this was 1.33, 1.366, 1.13, 0.90, 0.724, 0.455. So if I convert them into two decimal places to plot a graph, like example, this will become 1.37. This will be 0.72 and this will be 46. Then we have to plot a graph between the load P on y-axis and A over B on x-axis, and you do not need to begin the axes from origin. So we don't have to start from origin. So value of P, it's starting from 0.5 and ending at 1.5. So I can select 0.5, 0.6, 0.7. If you still begin with origin, your graph will not, yeah, it will not affect the gradient, it will affect the usage of the graph paper. Like your graph will be like not like you should use about 70% of your graph paper. So it won't be 70%, it will be less than. So you will lose mark for the axis. But it won't affect the gradient at anything. It will be same. So 0.5, 6, 7, 8, 9, and 1. So it won't fit. So if it is 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, it won't fit. So I should start with 0.5. So 0.5, 0.7, 0.9, 0, 1. So 1.0, 1.1 because 0.9, 1.1, 1.3 and 1.5. So that is P. And then here we have A over B. A over B does not have any unit, I guess. So it's you don't have to write any unit. And the minimum value is 0.4 and the maximum is 1. So 0.46, if I say 0.4, 0.6, 0.8, 1, 1.2, 1.4. So this is enough. Like this will be 0.6, this will be 0.8, 1.0, 1.2, 1.4, and then 1.6 will be there. Then we mark our result 1.5 and 1.37. So 1.5 and 1 point, each is representing, so this will be 0.38, 0.36. So this will be the first point. Then 1.2 and 1.13 and 1.2. So 1.2 is, this is 1 point, because each is representing 0.2. So this is 1.2. This is 1.02, sorry. Then this will be 1.1 and 1.12, then 1.14. So this is 1.14 and 1.2. So and this point should be here because 1.13 was there. So 1.02, this is 1.1 and 1, 2, 3, 4, 5. So this is 1.2, then 1.12, 1.14. So this will be here. Then 1.0 and 0.9. So 0.9 and 1.0. Then 0.8 and 7.2. So 0.8 and 0.78. This will be 0. 1 over B, this is 0.8 and yeah, P is 0.872. So this is 72. And then 0.5 and 0.46. So 0.42, 44, 46. So again, what we do, we draw a line of a best fit. But this, two points are above, 2 points below. As you can see here, like so this is 1, 2, 3, 4. So this is a line of a best fit we drew. Then determine the gradient. To determine the gradient, you have to show this on your graph. Take any 2 points. So first point on x-axis, x1, y1, x2, y2. So this is x1. x2, y1, y2. So it will be the gradient is y2 minus y1 over x2 minus x1. You have to show this on your graph. Like this is 1 point, y2 is 1.3, y1 was 0. This was 0.6, 6264. X2 is 1.2 and minus x1 is 0.6. What's the answer? The final answer for the gradient? What's the value for gradient? The final answer? 1.3 minus
1.1.
1.1, so 1.1. And usually like usually like 1.1, 1.2 is a weight of a meter rule or a meter scale. So the gradient value of a gradient is 1.1. So value of a gradient is 1.1. 1 mark is for the answer, 1 mark is for showing the working. And then they say gradient is equal to W. Like the value of the gradient and W are same. So gradient is 1.1, W is 1.1, and 1 mark is for writing the unit. The student has assumed that the center of the mass of a rule is at 50 centimeter mark. How would you find the find as accurately as possible the position of a center of the mass of a meter rule with no extra operators or material available? Like if, for example, if I have only meter rule and I want to find that where is the center of mass of a meter rule. So what I will do, I will pivot this meter rule at different positions until it balance. The position where it is balanced, that is the center of the mass. Because if the pivot does not lie under the center of the mass, it will cause a turning effect, like it will topple, it will rotate. But when the center of the mass or the weight is acting on the pivot, it does not cause any turning effect. So the meter rule will be balanced. So what we will do, if we have only a meter rule is available, so we will pivot the meter rule at different position. And the point where rule is balanced, that is center of the mass or center of gravity. That's how you can work out. Like example, if you have a ruler or the ruler or the scale which you are using. So if you want to find the center of the mass of your ruler, what you will do, you will use your fingertip and you pivot, like you use your fingertip as a pivot and you place the your ruler or the scale on your fingertip, and the point where it is balanced, that means that is a, like you will move the rule on your finger, the position where it will balance, that means that is the position of center of mass. Is it clear how to work out the center of mass of an object?
Yes, sir.
Then briefly state main difficulty that you would have in carry out this experiment. So the main difficulty for this experiment, difficult to balance the meter rule when the load is placed on it, and we can estimate the position before placing a load. So same answer is there, same repetition of the question. So this was balancing experiments. Is it clear? Any question or doubt related to the session today?
No, sir. Jazakallah.
So I'll end the session and share the related recording. Send solve the pages which we solved today. Send the picture of that.